Welcome. We are continuing and we are looking at the effects of the nuclear reaction. Remember in the previous lesson on the global issue, we have been able to look at the debates that are in science and the society. And we have been continuing to look at the nuclear power in Australia. As a matter of fact, it is important to note that nuclear is in the recent years developing high demand. The nuclear power is developing high demand in some of the industrialized nations. These nations are in high demand of energy. And because of this high amount of energy that are required in the both of their industrial activity, only both the fossil fuel cannot meet that demand. At the same time, we also have to look at the disadvantages of the some of the fossil fuel as we move on. Because one of the demerits of the fossil fuel is that they take longer. They take longer to be formed. They take longer to be formed. And actually they emit the greenhouse gas. They emit greenhouse gases. And result in what we call global warming. They may result in what we call global warming. And again, look at the expenses that are involved. Expenses and accidents that are periodically involved, especially in the mining of coal, and oil. Some of these disadvantages are now becoming notoriously increasing, because if we are going to damage our environment through global warming, and then the expenses that are still involved, they are affecting the economy. The economy is affected. I'm also seeing the environment is being affected, and because it takes longer time to be formed, when accidents occur during exploration, you will discover that the people in the society are affected. Still, the triple bottom lines are standing to outweigh the measures undertaken, especially in the fossil fuel. These are bringing out the demerits of fossil fuel. When we come to the effect of the nuclear reaction, as we have been able to look at them, you'll find that there is a high production of radioactive. There is high production of radioactive materials. One of the effects is that it is generating the radioactive wastes. These radioactive wastes, they are removed from the reactor fuel, which remains hazardous to the environment. They are actually very much hazardous to the environment. For example, I had given out that is mercury, and also there is an acid rain, that is acidic rain is experienced. This becomes elements that are destructive to the environment. And once these hazardous effects are felt on environment, it is not for 1 or 2 days. They are there for 1,000 years. That is why if we are also not very careful and taking the precautions effect on this aspect, we'll find out that for various reasons we may fail to build the nuclear reactors. But if we are very careful to look at its hazardous effect on the environment, it is actually there to remain for 1,000 years. And that is why in that lesson of radioactivity, just have to remember some of the half-life of some elements. They take longer time to be formed and to be reduced into less harmful effects. And another effect, because it is remaining on the environment for 1,000 years, you'll find that the environment will be in bad condition. The environment will be in bad state. Will be in very bad state. For how many years? For a longer period of time. That also means that if we have to produce what we call the crops for food, there will be a problem because the environment is in bad state. It cannot sustain the production of food, especially in the regions where the radioactive wastes are found, because they modify the genetic makeups of the human being and also some of the plants and animals. Therefore, where are we going to plant our crops for food? And remember, if this hazardous effect on the environment is remaining for 1,000 years, then we are going to experience a lot of problem in getting foodstuff, planting crops. Therefore, generally the environment will be in very awkward state when we are not very much careful. Therefore, we have to take various precautions measures on how to go about the effect of the nuclear reaction in generating of what you call nuclear power. At the same time, when we look at the other effects, there are several effects that might emanate on it. Some other materials such as uranium they have very vital and very important utility on the environment, because uranium has some advantages when we look at it. For example, uranium is a long-lasting. Uranium has a long-lasting supply of raw material. It has a long-lasting supply of raw material. When this raw material has been supplied for a longer period of time, in the places where it's going to be used, it produces a lot of energy. A lot of energy is produced that is in large capacity. That is, when we look at uranium basically, and also another thing from the uranium does not produce the greenhouse effect. The grain that does not produce greenhouse gases. Therefore, the greenhouse effect, the greenhouse effect that is always obtained or felt from the greenhouse gases is avoided. And such greenhouse gases include methane. We have the carbon dioxide. That is carbon dioxide. We also have another example of nitrous gas. That is nitrous oxide. And also another one that is also emitted, it becomes one of the greenhouse gases, is the chlorofluorocarbon. Chlorofluorocarbon. All those gases that are related here, they have an impact on the environment. Therefore, when uranium as a reactive material that is found in the nuclear power, it has got a better supply of raw material. Yes, it does not produce a lot of energy. It actually produces a lot of energy that is in large capacity, and does not produce the greenhouse gases such as methane, carbon dioxide, nitrous oxide, and chlorofluorocarbons, and other gases that are termed as greenhouse gases. Therefore, it is less harmful to the environment, very less harmful to the environment. When we look at it very carefully, then we are going to find out these are some of the better part of the uranium, which is also used as the materials, as a supply of the raw material in the nuclear reaction. But now, having looked at its disadvantages, having looked at the advantages, I mean, do we have any demerits or any effect that we may experience during the construction of the reaction or the reactor? Yes. You'll find out that it is very expensive. Very expensive to put up nuclear reactors. It is very expensive to put up or to build nuclear reactors, and that gives us a disadvantage. And some of the waste from the nuclear power reactors are difficult to dispose. Some wastes from the nuclear reactors or from the nuclear power are difficult to dispose. They become difficult. They become difficult to dispose. Why? They do not just require a careless disposal, they require safety storage. They require safety storage for longer period. They actually require safety storage for longer period. And that becomes an effect that we can be able to feel. Then sometime this uranium, when we explore and depend on uranium, it is exhaustible. Uranium is exhaustible source of energy or a source of the raw material. Once uranium is exhausted, that means it is depleted at a given time. Can also say depleted. Uranium can be depleted or it is exhaustible. Source of raw materials for the nuclear power reaction so as to produce energy. Having looked at the effect of uranium itself, which is used in the nuclear reactors, therefore we understand that there is a cost that we have to bear. For example, the cost of putting up nuclear reactor is very expensive. These affect the economy. And because the nuclear power, some of the wastes are difficult to dispose, it becomes an environmental problem. It is going to pose somewhere an environmental problem when it is difficult to dispose. Although, if we avoid it to be an environmental problem, we have to take measure of safety storage for longer. That means we should have an alternative planned for storing nuclear reactors wastes for another period, longer period of time. We'd like to demonstrate this in this way. For example, we have a nuclear plant that is a nuclear plant, I'm using symbolic diagrams. If this is a nuclear reaction plant, with all that it have, we can label it A. This is where all activity of fission and fusion occur so that we can be able to produce electricity or energy. And then what about the wastes? These wastes should be made in such a way that they can be disposed on what we call nuclear wastes plant or nuclear wastes. Yeah, it can be a plant because this one will protect this environment or this area from being accessed by human being. Therefore, all these wastes will be discarded and disposed here, and at least we are a guarantee they can stay here for almost 1,000 years. That becomes a safety measure that seemingly scientifically it can be taken so that it is coated everywhere to prevent further reaction with other things. Putting only up this plant A is quite expensive. At the same time, the cost of taking care of the environment require that we put up plant B so that it's going to take care of the nuclear waste products that are going to be dumped and disposed on this plant. And while on this plant, they will tend to take longer period of time here so that their half-life nuclear reaction is reduced to less and lesser harmful effect. Therefore, that becomes a scientific idea that maybe for the countries that will require to manage in putting up nuclear reactors, the positive aspect of it and the negative aspect of it, we need to consider them so that we avoid the costs on the economy, on the environment, and also on the society, avoiding hazardous damage. As also a result of this, it is also quite important when we look at most of these effects of the nuclear reaction and generation. Let's see on the other side, as we compare, as we make a comparative or a comparison of this reaction and also that is the nuclear reaction and the other aspect of the energy which is supplied from the carbon dioxide emission. We'll be able to look at it in a form of understanding the concept, and then we look at the question. Therefore, it is good when we handle little bit of the questions and the concept will be able to be clearly understood Still on the part of it, we have to review this question and make it for us. Why do you think science alone cannot answer the questions? Why do you think science alone cannot answer the questions on global issue? On global issues, it is very, very much important. This will be helping us to understand the previous concept. It is indeed important that science alone cannot answer the questions on global issues. Why? Because some of the science and technology is ever changing. And because the technology and the science itself changes, there are some tremendous changes in the society. Because of these changes that happen in the society, some of these changes are regarded as positive changes, and they are viewed as a progress in terms of development. While other changes are environmentally hazardous, that becomes a negative change. And when there is a negative change on the environment, therefore it poses a questions that the science alone cannot be able to answer. The questions on environmental issues, because the new problems are introduced always from the scientific and the technological innovation. This triggers more problems. That becomes a better concept. Let's look at the second question. Outline 4 issues that are being debated in Australia. Outline 4 issues that are being debated on in Australia. What are these 4 things that are being debated time in, time out in Australia? Just to outline them, it's very simple. The question requires us to cite those areas that are bringing out the global issues in the debate of the limelight. For example, humans are the cause. Human beings are the cause of global climate change. Human beings are the cause of the global climate change. That is one of the issues that is being debated on. And then another one, seemingly the one that we are discussing, nuclear power should be built in Australia. That is a debate. nuclear power should be built in Australia? Should we build nuclear power in Australia or not? Others rise up and say it should be built, while some other debaters say that no, it should not be built. Is it appropriate to transplant, or is it good to do xenotransplantation? Is it appropriate? To do that is to do xenotransplantation? Is it appropriate to do xenotransplantation? Should genetically modified crops be adopted in Australia? Genetically modified crops adopted in Australia? These, among other debates, become very crucial and very important among other issues that are bringing out the debates that are necessary to be discussed and have their best and possible scientific solutions about them, bearing in mind they should come up with some scientific evidence that should be available for them to be discussed. Let's look at the question 3. Let's look at question 3. State 3, not 3. State any waste product that is obtained from nuclear reaction, that is nuclear power reaction. There are always some of the waste products that emanates from the nuclear power energy. As a matter of fact, most of these are just, it is very good to highlight them. We have mercury. Another waste that we may be able to obtain that becomes very harmful. We have thorium. And some of the given extent, we have the uranium waste products. I've added them to be 3, but majorly it is mercury, thorium. From the environmental effect, we have the acidic rain. We have the acidic rain. This becomes environmentally hazardous, and therefore it is an effect. It is a waste product that emanates on this. As we move on, let's try and look at the graphical information that we are able to understand the bottom line of these values. Okay, when we look at the graph below, or these graphs, as we study it very careful, this graph shows the energy which is released and also the carbon dioxide which is emitted in the country of Australia for the 4 fossil fuels which are listed. Now, the fossil fuels which have been listed here is the black coal, we have the brown coal, we have the oil, and we also have the natural gas. These are the 4 fossil fuel which have been listed. Therefore, graphically, the energy which is released from the black coal is rated at this percent. That is not percentage, it is released in terms of 1,250 megatons that are released. And as we look at it, we understand the carbon that is released. Let's look at the key. This is the amount of energy released that it shows and the energy which is emitted. Now, that is emission of the carbon dioxide is emitted on this key. This will give us some good amount of information. Therefore, we'll have to use this graph and respond to a few questions here. Which 2 fuels produce the greatest carbon emission? Which 2 fuels produced the greatest emission of carbon? We have to identify from this graph the 2 fuels that emitted a lot of carbon graphically. And the emission of carbon is also measured. For example, black coal, this is the emission of carbon which has been rated at 1,550. When we look at this one, has been rated around 850 for the brown coal. And then the natural gas has been rated around 1,150. These are the tons that are released. When we come back to this question, the greatest emission of carbon is on this value. We have 1 is black coal. That becomes very interesting. And another one is the oil. These are the 2 fuels that produces or emits a lot of carbon. And its effect, we are going to find it in the environment. State the effect of emission of black coal and oil in terms of carbon. You will find that this emission of carbon from black coal and oil, it produces what we call the greenhouse gases. Produces the greenhouse effect. which are the greenhouse gases. And therefore, these gases normally culminate in the air. As they culminate in the air and the space, then they have a challenge of increasing the temperature. The global temperature will be increased, and as a result of that, it leads to what we call global warming. It leads to what we call global warming. It is very, very much important. Let's look at the other question. Which fuel produces the least energy? Which fuel produced the least energy? Now we have just to look at the graphical, which is also scientific representation of information. We look at this very simple bar graph and find out which was the least producer of energy. The least producer of energy. The least producer of energy. If we look among the black coal, brown coal, oil, and then natural gas, we quantify each of them according to the rate. The least producer becomes the brown coal because it is rated at 500 tons. That is, brown coal is the least producer of the energy. That becomes very important. It becomes very much important as we are able to look at it. Let's look at the next question. Question 3. Rank the fuels according to their greenhouse effect potential. Rank the fuel according to the greenhouse. According to the greenhouse. The greenhouse effect potential. This one, they are looking for an order. We have to find out an order in which most of these produce the greenhouse effect, their potential of producing the greenhouse effect. That is the best ranking. We begin from the highest to the lowest. Highest, and then we go to the lowest. This is scientifically ranking. Therefore, which produced the highest greenhouse potential comparing with the energy released or the energy supplied? You will find this part is greater, and then followed by this one, and then followed by this natural gas, and then this becomes the least. Therefore, we have to rank. This becomes 1, this is 2, relatively this is 3, and then this is 4. Therefore, in the order is black coal, and then after that we have the brown coal, Then we go to the natural gas. And lastly, we come to the oil. And we become very happy looking at the questions. We have answered it correctly, basing on the analysis that we have. That becomes good. Explain why some fuel accounts for more of our energy needs than others. That is question 4. The question asks that we explain why some fuels. Explain why some fuel accounts for more. Explain why some fuels account for more of our energy needs than others. Why? Why do some fuel accounts for more of our energy needs than others? The reason is because most of these fuels are more abundant. Most of these fuels are more abundant. They are more abundant and easier. They are more abundant, easier, and they are also cheap to access or to mine. That is the reason why some of the fuels will be able to account for more of our energy needs than others. For example, oil accounts for more of our energy needs because it is easily accessible, it is also cheap, and it is abundant naturally. When we compare it with the brown and black coal, therefore it also becomes essentially challenging, or essentially in this way. It becomes also very, very vital and more important as we look for this. Therefore, having looked at these questions, then we are able to understand the concept of the energy, especially in Australia, and how it emanates, it becomes as an alternative. At the same time, this is an already utilized resources, has been rated in this manner. Of course, if we could be able to find the energy emission of the nuclear power, or maybe from the nuclear power reactions, we could be able to compare with these so that we found out the best and the suitable supply of energy in the cutting edge of our technological world. But because we have only managed to come up with this graphical information about the black coal, brown coal, the oil and the natural gas, these are the fuels which have a potential effect on the greenhouse gases on the environment, of which we should make decisive information to adapt them very, very much easier. Also, as we move from this part, we have been able to find out more and more of the information about the nuclear reaction. Just also the last question to remind us about the nuclear power from the radioactivity. We'll have to state two kinds of reaction. Two kinds of reaction. I have to state two kinds of reaction in nuclear power generation. The two kinds of reaction here quickly for us to remember is fission. I hope you are understanding that. And also fusion. These are the nuclear power, the nuclear two kind of reaction in the nuclear power generation, and it becomes better and best for us. Let me also bring out this part, differentiate between nuclear fission and nuclear fusion. This is a good question for us or for you to be able to answer in this concept, so that as you answer this concept, then it is vital, it is quite important. This was question 4, this question 5. I will give you this question as a homework for you. You have to differentiate between the nuclear fission and the nuclear fusion. Question 6. State 3 types of emission. Three types of emission. State 3 types of emission during the radiation. State 3 types of emission during radiation reaction in nuclear generation. That is in nuclear power generation. What are these 3 types of emission during the nuclear power generation? This one becomes a very important for us. One, during the radiation or during the radioactive radiations, there are 3 types of emission, and one is the alpha radiation, that is alpha radiation. We also have the beta radiation. It emits the beta particle. And then lastly we have the gamma radiation. Okay, these are 3 types of radiation which emits. What is the emission here? They emit alpha particle. Then they emit alpha particle. This one will emit beta particle, and then the gamma radiation will emit gamma particle. It will emit gamma particle as a result of the nuclear reaction. That reminds us that it was very important for us to have covered the radioactivity, which we did it very well on our major lesson in the previous level. Having gone through these 6 questions, they have been helping us to understand and review the concept of the nuclear power in Australia. We have also been able to look at its effects on the environment and tentatively thinking out, exploring out, brainstorming the ways out of how we are supposed to come up with the nuclear power generation, especially to our energy demanding industry on the countries such as Australia and any other country. This has become a very vital, important also to understand the bottom line, the 3 bottom line principles of evaluating the energy demands and also coming up with the nuclear power reaction. Hope with those very few remarks we have had a very good session and lesson. Thank you for paying us your attention. Have a good day.